Hello, everyone, and welcome to today's live broadcast, Extraction and the Labeling of Cannabis Products, presented by Jahan Marcu, Ph.D., Chief Scientific Officer and Chief Auditor for Americans for Safe Access and the Patient-Focused Certification Program. I am Judy O'Rourke of LabRoots, and I'll be your moderator for today's event. We are delighted to bring you this educational web seminar presented by LabRoots. LabRoots is the leading scientific social networking website and producer of educational virtual events and webinars. Before we begin, I'd like to remind everyone this event is interactive. We encourage you to participate by submitting as many questions as you want at any time you want during the presentation. Just click on the Ask a Question box located on the far left of your screen and type your questions into the drop-down box that appears on the screen. We'll answer as many questions as we have time for at the end of the presentation. If you have trouble seeing or hearing the presentation, please click on the Help Desk button located in the promotional board at the bottom center of your screen, or use the Ask a Question box to let us know that you're having a problem. This presentation is educational and thus offers continuing education credits. Please click on the Continuing Education Credits tab located on the top right corner of the presentation window and follow the process to obtain your credits. Please join me in welcoming Dr. Marcu. I will now turn the presentation over to him.
All right, hello. We're going to be discussing extraction of cannabis products and the labels of these products today at this webinar. The topics we're going to discuss is research on comparing extraction methods and solvents. We're going to discuss the issue of pesticides and products, as well as some studies that we've published on the label accuracy of different products. When it comes to extraction, we generally look for trichomes. All plants, a lot of plants, most plants make trichomes, and we have to wonder why they're there. Which is a great question that no one in the audience asked. And they're not really there for our pleasure. They're there for reproduction and defense. And they come in three different types. And this is important because when we talk about cannabis products, the essential oil, the cannabinoids that is put into products, that is formulated, is coming from trichomes, from very particular parts of the plant. And so they come in three flavors. There's long multicellular stalked ones, like you can see by the letter E on the far right-hand side, but there's also short ones or ones that have no stalk but have multicellular heads. And this figure here just is from our monograph on cannabis inflorescence, which is cited in a lot of state laws as a standards for taxonomic identification and identity analysis. And so the reason it's important to know about trichomes is if you're just using your basic scientific instrument, the microscope, for example, you can look and identify glandular versus non-glandular trichomes. Why could this be important? Well, if you're targeting a part of the plant that has those thin, wispy trichomes on the bottom of this slide, those are not going to produce cannabinoids or potentially the useful therapeutic compounds that you're hoping to extract, like THC and CBD. Up above those, the first three image is from the top. Those are the glandular trichomes, and they're located on the fruiting bodies of the plant. You're not going to find these trichomes on the stalk of the plant. And this is important because your extraction efficiency is going to depend on what part of the plant you're targeting. And this is from a book chapter published by Ethan Russo and myself last year entitled Cannabis Pharmacology, The Usual Suspects and a Few Promising Leads. Happy to share the article if you guys want to send me an email. But starting with our cannabis plant on the left, if we were just to start to break off the fan leaves and the stems and the roots, we would find little to no cannabinoids or terpenes there. Very, very, very small percentage, and probably it might be considered contamination where the flowering tops of the cannabis are dripping oil. Moving to the right, if we look at an unfertilized flower, the female plant, we can find up to 30% by weight, cannabinoids and terpenes in some samples of those. If you have fertilized flower tops, like for example in some hemp or parts that are producing seeds, the oil production is going to drop drastically down, up to 13% maximum. Now, if you're just targeting the trichome, say with mechanical separation or something like that, you can get up to 60% cannabinoid by weight and upwards of 8% of the essential oil. Seeds and sprouts do not make terpenes or cannabinoids. They're a great source of essential fatty acids and cannaflavin as well. But again, seeds, stalks, roots, these are not real sources of cannabinoids. So I'm going to go a little bit back to the basics as we move through this, talking about chromatography. So there's a couple different things we can use to separate out compounds and analyze them. And they're not all created equal. They have their pluses and minuses. And I'd like to just talk about some basics of that. So we have thin layer chromatography, which is useful for characterizing cannabis and its major cannabinoids. It has its uses in qualitative measurements, not ideal to give you precise numbers in most cases, but it's great at looking at are the products decarboxylated, has it degraded? It can give you some nice yes or no answers. HPLC, high performance liquid chromatography, is great. It's my preferred method for looking at phytocannabinoids in cannabis. There is gas chromatography, but there is a derivatization step required, and that can limit its usefulness. And there also are a variety of other limit tests that can be used. So what is chromatography? Well, it's a technique for separating complex mixtures into their components. For example, you have a mixture of jelly beans. If we had a magic chromatography machine for jelly beans, it could separate them out into their different components. And this is important because chromatography, as you might have guessed or know, is not just used for separating compounds for analysis. It also can be used to isolate and purify different types of compounds. Now, flash chromatography is a really interesting one that can be used for isolation or as a preparative step in chromatography. You also have supercritical fluid chromatography, CO2 extraction, as well as centrifugal partition chromatography, which is a way of using centrifuges to separate compounds with chromatography. And likewise, those share that same technology is used to fuel our analytical techniques, the techniques used to generate numbers and things like that for labels. And in case you didn't know, HPLC basically works by taking a complex mixture and separating it out into its individual components. So on the right, we have an example of a flash chromatography machine, the instrument, as well as the columns. And the add-ons and ancillary pieces can make a big difference in what you're determining. And so to give you an example, this is an HPLC for major cannabinoids. Now, I mentioned ancillary equipment in the last slide. This includes your detectors, and this will stand out in this example. So here on the left, we have standards. All the same amount of these cannabinoids have been spiked into this sample. Now, you might be looking at this standards graph on the left from the American Herbal Pharmacopoeia Monograph saying, well, I thought you put in a milligram of each cannabinoid here. Why are these peaks different? Well, that has to do with your detector. These cannabinoids don't all respond the same way to the same length of UV light. So you might get different peaks and you have to account for that. And so when we look at the raw plant material, just because there's a really large peak of THC acid doesn't necessarily mean that it's the most abundant thing in there. It could actually be that there's more THC than THC acid. And so definitely when you're looking at these chromatograms, it's always important to know what sort of things you're using, because not all detectors are being used. And I think this has caused a bit of an issue with some people working with plants throughout time, because sometimes compounds can coalute and cause some other issues. And we've actually seen that a lot of labs are doing a sort of quick and easy HPLC method are sometimes coaluting peaks and counting them as THC. So when you're choosing your detectors, it's really important to get something to use more than one. Now you have a UV detector. Like I said, compounds are going to respond differently to that, even related compounds, and some may not even be visible, maybe a potential contaminant. Likewise with MS detector, maybe it's not visible by mass spec. But there's also evaporative light scatter detectors, which can detect everything. They're not quantitative, but using this conceptual example, you can see why you might want to use different detectors for different samples. Now, There are a lot of different types of products on the market, and we're going to go through those products, what they are, how they're extracted. And then at the end, I have a rating system I've developed with colleagues at the American Chemical Society, Ezra Pryor, who's a former chair of the Cannabis Chemistry Subdivision, for rating these systems in sort of a subjective matter based on safety and efficiency and cost. So among the products on the market are oils, waxes, and other things called shatter. So oils typically are characterized as being low potency or not, but it basically describes its viscosity. It could be black, yellow, brown, or colorless. I think the sort of one that people think of as that thick blackish oil on the right. Waxes, this is more of a semi-solid at room temperature. This may be sort of the least clean in terms of how it's extracted. We'll show a little bit of that later. But this is sometimes referred to as butter, cheese, crumble, or earwax. So you can see it kind of has this soft, pliable nature to it. Now, shatter is the layman's term for this very high potency product. Varies in its quality. It's been winterized often, and it's devoid of waxes, many fats, solids, and other substances, and often has a clear consistency, as you can see in the bottom. And each of these has their own ways of extraction, or you might use multiple methods. So you could have a CO2 extract that's further processed from a waxy substance into a shatter substance. The oldest and most traditional ways of making cannabis extracts are through mechanical separation. This has been done for thousands of years. It's gotten a slightly bit better than people just rubbing their hands together with some cannabis and scraping it off, as it was often done in ancient times. And so on the left, where you see the penny, is a picture of some traditionally made hash, and this was done through pressing. You also have other types are wet or dry automated. So making hash, so you can use screens or sieves to collect and press. On the right, we see rosin tech, which is basically taking an extract, or in this case, a flower, and pressing it. Now, this is a very pure product, but it's an incomplete extract. It gives a great profile of the compounds, but you're leaving a lot behind. So one of the drawbacks of rosin tech would be that it creates a very pure product, but there's a lot of waste left over. Ethanol extraction has a few benefits. It has less of an impact on the environment than other solvents. Ethanol can be produced in-house. Ethanol is non-toxic at low levels. And on the right here, you can see an image of a hot plate with, it's basically an ethanol still. Now, ethanol extraction has been used for a long time by botanists and other people to make tinctures. And actually, the licensed pharmaceutical known as Sativex is an ethanolic preparation. It starts off as a CO2 extract, but is ultimately dissolved in ethanol. Now, the drawback to ethanol is that it can be very expensive to purchase. There are legal concerns when producing or selling tinctures, but just using ethanol by itself will produce an impure crude extract, and it's also a flammable gas, so there's extra precautions you may want to take. Now, CO2 extraction has a lot of benefits. It's non-flammable. There's less of an environmental impact. There's no trace solvent left behind, no toxicity at most levels, and it can be made to be selective. However, it can cost a lot of money to get started. Typically, unless you're a pro or a savant at this, terpenes are typically lost during the extraction of the flavor and smell profile. It's typically a dark product, and there's a fixed throughput. And this is good for modern standards because you have to have an actual and theoretical yield and reconcile that to help control diversion and other issues. And so CO2 does have some benefits there. Now, so CO2, to continue our discussion about CO2 extraction, when we talk about winterization, we're not talking about, insulating or sealing up your home vehicle. In this case, it's a de-waxing process. So when we talked about going from those semi-solids to those clear substances, this is typically done in 95% pure ethanol at sub-zero temperatures. The waxes precipitate, as you can see at the right at the top of the vessel, and are filtered out. For best results, this is repeated multiple times with a centrifuge and filter. Many, many methods exist for this. This wasn't invented recently. And a lot of these techniques for extraction are used in the herbal products and botanical world and have been for a while. Butane. I'm only talking about closed loop systems. These are some pictures of what a closed loop system looks like. You may notice there are some subtle differences between this and what you might find on social media about butane. I'd like to point out that there are no canisters that aren't connected to a hose. And I think that the benefits, really, the only benefit I can think of for butane for most is the low startup cost. But with regulations, these also have to be in blast-proof rooms or in appropriately ventilated areas. So it's an explosive solvent. There's no shortage of bad PR images about this. The solvent can cost a lot when you're using the right grade of solvent, and selectivity can be lost with elevated temps. And it also can produce a low purity crude extract often. It'll just take everything with it off the plant. Open loop or blasting, I would say just don't do this. It has a negative impact on the industry. It's dangerous for the producers, it's dangerous for the workers, it's dangerous for the consumers, and it is a public health issue. If you want to see a video of this, we have it. You can go check it out on YouTube. But again, do not do this. It is a bad idea. So some of the more traditional ways of making cannabis are still used by the industry today. These images are courtesy of Ethan Russo. So the benefits to dry sift hash, such as keef, are the low startup cost, ease of production. It's a solvent-free process. You're not even using water to do these extraction. The terpenes are easily preserved. Now, our waxy trichomes in the leaves are very, very good at preserving what's on the cannabis plant during its curing process. And so on the top left, we see a harvested piece of cannabis, a whole plant, I believe, or a couple of them bound together from Morocco. Is a close-up image, and on the right, an example of it being chopped up next to a pile of chopped up tobacco. That can then be run over a screen, as you see in the bottom, that stainless steel tray. And it can use to be pressed that fine powder that you see in the plastic bag that has the hand contaminating it. Probably use gloves and practice aseptic techniques. And then you can see that just a picture of what the substance looks like while it's burning. It's a pretty pure product, still has a fair amount of waxes. And this could be pressed into a unit as well. Another area that is people are interested in is distillation. It is the action of purifying a liquid through heating and cooling. Again, you take advantage of the chemical properties of their boiling and vapor points and use to separate mixtures. But again, this cannot separate individual cannabinoids, more like groups of them, as you can see by the temperature, as well as different terpenes. They weigh slightly different weights, so they're going to evaporate at slightly different temperatures or different molecular weights. Now, I think it's important to say that this is a bit of an art to doing distillation. It's here a lot of it's a very steep learning curve. It's very difficult, I think, for a lot of people to master this. Now, cold water hash extraction is an interesting method. It's a low startup cost, ease of production. It's typically what we would call a low solvent-free process. It does use water, which I know is a solvent, but you're not using butane or ethanol or something like that. Terpenes are very well preserved in this process. And this is a series. These are bags, and so ice water will be loaded in here with probably frozen cannabis, and it would be pulled or strained through a succession of smaller and smaller screens. Now, the drawback is that potency typically doesn't exceed 50% of the active ingredients. It has a low market value. It's labor intensive. These bags are huge and people have to pull them up. And a lot of other particles may be included in there. You could have a fairly good size exclusion, but contaminants are not typically removed during this process either. So it does have it seems to have a high failure rate for QC in the cannabis space. So to sum this up, the extraction comparison method, there are 4 typical methods we discuss: mechanical, classical separation, the alcohol, ethanol separation, light hydrocarbon extraction, such as butane, as well as CO2 extraction. And we've rated these subjectively according to safety, cost, quality, environmental impact, just on a 1 to 4 scale. So mechanical separation, for example, gets a 4 because there's no danger of people things combusting. The cost is very cheap, but the quality is much lower than other stuff. Its environmental impact is very low. There's not a lot of waste generated that can't be composted or recycled. So it gets a score of 81%. Alcohol and light hydrocarbons have safety issues, cost issues, and potential environmental issues, which give them lower scores. CO2 extraction is the medium between mechanical extraction and light hydrocarbon extraction. It has a high safety rating, but it also has a high cost. Quality of the products that initially come out are okay, but they generally require further processing. There's also less of an environmental impact. But all techniques, as we'll sort of discuss, have some product safety concerns, but mechanical and CO2 are the safest for workers when properly used. So let's start to put this all together into a study. So we've talked about all these extraction solvents, but has anyone sat down and compared them side by side in a controlled laboratory? Yes, at least one group. So Americans for Safe Access works with the International Cannabis and Cannabinoid Institute. It's their research partner, and you can find out more about this research at ICCI.science. These results were done in a patient-focused certified and jointly ISO-accredited lab at the University of Chemistry and Technology in Prague in the laboratory of Jana Hašlova. So what we did is we helped to standardize some cannabis herba samples, some hemp flower, and we would homogenize those samples, take about 5 milligrams, put it in whatever the extraction process was. In this instance, it was an ethanol-methanol mix, shake it for 30 minutes, and filter it, and then load it into our UPLC with tandem mass spec. So when you look below at the cannabinoid profile, we compare different extraction procedures for ethanol, methanol, CO2, and then we used water as a control. And so as you see here in these, it's a little hard to see, but if you look at CBD acid in the first column, the green, red, and blue bars, they're different amounts. And that means because ethanol, methanol, and CO2 all have their different sort of efficiencies for extracting compounds. When we look at some of the other cannabinoids that are pulled out in that blue bordered box, you can see that THC, THC acid, CBG acid, all have slightly different efficiencies when being extracted from the same plant material. It's really interesting to see how well ethanol extracts THC acid. But what about the terpenes? Good question that no one asked. The terpenes, and this is a slide from the students at the Czech Republic, and I have the next slide. Some of these are translated in English, but I thought this provided a nice sort of snapshot of what it looks like. So we have ethanol, CO2, and water extraction represented here. You notice right away that you look for humulene right at the top, it is really well extracted in water, not so well extracted in the green ethanol. In CO2 extraction can be pretty efficient at it, though. It's sort of a medium. It's pretty interesting just to see that there are differences. So when we move and we just sort of pull out some of what I would consider the more interesting compounds, my bias, we can see like pinene is more efficiently extracted in ethanol, which is very interesting. Pinene actually has pharmacological activity. It is a bronchial dilator. If you go into the woods and breathe it in, your lungs will expand. So if you have a product that's formulated to be inhaled, this could be an important component. It's also an acetylcholinesterase inhibitor. So combining this with THC would potentially synergize some of the alerting effects of THC, similar to, your mind might feel like it's racing. Not something ideal to, say, take for sleep. And so if pinene is an important part of your product, changing from CO2 to ethanol or ethanol to CO2 might really change your product. And what this says is you could start with the same material, put it through different extraction procedures and get a different profile. For example, another one is myrcene. Again, it seems to be more favorable to extract it through ethanol. This compound is heating, and when potentially enhance the sedating qualities. So if this is not something you want in your product, maybe using CO2 would be an appropriate method. Ocimene was a really interesting compound, very, very highly loves to be extracted in CO2. And ocimene is a really interesting compound because it's a new compound law enforcement is using to train insects actually to detect drugs. So drug sniffing dogs use a croffeline derivative. But honeybees really love ocimene. It helps regulate their social colonies. And so a year or two ago, law enforcement published a paper demonstrating that honeybees are really, really good at detecting ocimene in packages and things like that. So the new drug sniffing dog are the honeybees. I think it might be, so look out if you go to the airport and you have bees gathering on your backpack. So ICCI also did a follow-up study to this where they ordered a ton of CBD oils on the market and looked at these products. We looked at the CBD content. Does it meet its declared or legislative limit? For example, is it within 10% of the value? For THC, sometimes for a lot of these hemp products, it has to be 0.3% or less. However, what was interesting is most of these companies didn't list the THC on the product, but then again, it wasn't exceeding the legislative limit. They were spot on for the amount of fatty acids in these 29 products. But what was interesting is we saw the benzopyrenes and polyaromatic hydrocarbons skyrocket in some of these. And these are like that stuff you might think are like the char marks on a burger if you go to a barbecue. How bad is it for you? You don't really know, but what was interesting is we were seeing these forms. So what this might be from, we speculate, we've contacted these companies and are working with them, is that this might be from the addition of terpenes or from poor storage conditions or from long storage conditions. Some terpenes do break down into polyaromatic hydrocarbons. So if they're adding synthetic stuff to it for flavoring, this might be another consideration for quality control. How long are you going to store them to prevent this breakdown? So I want to just say a little bit about personal protective equipment and things for considering. Footwear, lab coats, glasses, goggles, gloves, respirators, and signage. Any cannabis extraction facility should have all of those appropriate things. Part of my job with Americans for Safe Access is going and assessing regulatory compliance, preparing operations for regulatory inspections. I give out a lot of citations or CAPAs for not wearing proper footwear, for lab coats being worn outside the lab, not having glasses or goggles available. Some equipment is irreplaceable, like your hands. So always having the proper gloves to use. If you're working with stuff that's really cold or really hot, you want to have proper glove use. Respirators is another issue. You need to be medically fit tested and have proper procedures in place for their maintenance. These are heavy OSHA fines that we're seeing. So exposure and first aid, think OSHA, right? Workers could be exposed to a lot of things. Having worked in cannabis operations in the past, I have to say that sometimes you don't know what's been used on the product. And if they're working with it and the product has pesticides perhaps, or maybe you're processing it in a way, or maybe it's made with solvents and it needs to be purged, or it could be the cannabis. I have a colleague who's allergic to cannabis and she'll break out in hives if it touches her skin. So you have to think about worker safety and exposure to these things, especially if you're a manufacturer and you're bringing in lots of cannabis. Additional health concerns are that not all terpenes are grass for inhalation. They're not all generally regarded as safe. A lot of these are synthetics, and there's an interesting condition called popcorn lung disease that's popped up. And that's from chronic long-term exposure. There's also some concerns over propylene glycol when overheated. It's used in almost all e-cigarettes, but when exposed to really high temperatures for a really long time, formaldehyde-releasing bodies can be found. So having, really finely calibrated instruments or vaporizers is also key to safety. I'm going to talk a little bit about pesticides. Again, for these things, you want to choose the right instrument for what you're looking for. Worker safety in the analysis and extraction. You definitely don't want you should treat every product coming into your facility like it might be contaminated. You don't want your employees touching something that has pesticides and touching doorknobs and radios and other stuff and spreading it around the lab. And this is from the American Herbal Pharmacopoeia Monograph. And this is just showing you just that here are some pesticides, their classification, and some instrumentation methodology that has been cited and used. So here are some things we don't really know very well about cannabis. On the right, you can see a picture. This is one of my favorites. It's from a facility. They had taken in product. This is what the producer had put on the label before extraction. And if you look at the ingredients, it all seems pretty fine, except when you get to the bottom and it mentions that myclobutanol is one of the ingredients in the material. And again, we don't know at what level, right, just from looking at this, but it might be a good idea to think about your workers being exposed to this chronically. And there is research on this that you guys can look up. The factory workers who make this stuff wear all sorts of equipment to prevent them. Another consideration is that this might increase during the extraction process. So if you're concentrating the stuff in cannabis, you might accidentally be concentrating the bad stuff. Is it transferred during smoke? Yes. How much is it absorbed? We don't know. What pesticides are you looking for in your state? It's difficult because it's hard to know. The regulations vary. There is no EPA-approved cannabis product. Typically, when we're trying to do compliance assessments through a third party and help these operations, typically we just go to the local grow store and see what they're selling, and chances are the operators nearby are using those. But there are solutions such as integrated pest management, and agricultural science training is highly recommended for cultivators. And you should always test your product before and after extraction in case you've concentrated something or there's been some contamination. And that's why cleaning validation protocols are really important. And so cleaning validation protocols, testing products before and after extraction could have prevented some other issues. So this is just a study. I just wanted to show that, there are no EPA tolerances or FDA real tolerances for pesticides on smoked crops or inhaled crops, but up to 70% of residues will persist in cannabis smoke. And this is the first study really of its kind, and it was done by a licensed cannabis laboratory in Washington State. And so I love this because it shows that the cannabis labs are actually playing a pivotal role in providing information to inform policy. So a distillation from a pesticide study published by Dr. Russo in 2016, he said, to fully assess the situation, 20 distinct cannabis samples were purchased, 24 concentrates or extracts, and 2 cannabis inflorescents that are, whole flowers from legal stores in Washington, so adult use stores, and passed through witness chain of evidence to a certified legal licensed laboratory. What were the results of that study? 22 of the 26 samples tested positive for pesticides, 84%. Many harbored multiple contaminants, attaining levels in terms of even hundreds or thousands of parts per billion. So this includes 24 distinct pesticides. And we're talking about all things that are pesticides are things that kill bugs or even fungicides. So these could be growth regulators and things like this. Bees are attracted to cannabis, like I said, because of the ocimene. And a lot of these things will kill bees and enter into the food supply as well. So, I think that we have to be thinking about the environment as we're applying these things to our products. And, California, Washington State, and Oregon allow outdoor cultivation. So one of the really bad actors that was found in one sample was a cholinesterase inhibitor, a carcinogen, and potentially a reproductive toxin. And this is a carbamate insecticide. In one sample, it was found to be 255 times above the allowable limit for any product, whether it be even a t-shirt or a fiber. It was found highly concentrated in one sample. So to summarize that up, 15 to 30% of the samples at one California lab were positive for pesticides. Some of them were nasty, some of them not so nasty. But If you want to look at more information, there's some resources here about those and references to the studies we've discussed. So the last thing I'm going to wrap up with is talking about a labeling study we conducted. And this looked at the cannabinoid. Basically, we ordered over 80 CBD products online, and we looked at their content, whether they were accurately labeled. And the first study of its time was just on THC products. So this is just saying we looked at THC products first, and what we found, 5 THC containing products, about 17% were accurately labeled, 23% were underlabeled, and 60% were overlabeled with respect to THC content. And so what this shows is extraction and applying it can be tricky. And the more we know about solvents and the processes, the better and more consistent we can be. So we looked at THC products first, and the second team looked at CBD products, 84 of these products, oils, tinctures, vaporization liquids. And we basically, as you can see, there was an issue with things being accurately labeled under or over. So in this study, you had about a 50% chance that a CBD product ordered online would match what it says. And then the other 50% was split between being under and over that amount. And this is just showing you what the average milligram per mil of the different components were in these extracts that were sold online. So to summarize this, there's a couple takeaways. One is that the cannabis oil that has the therapeutic compounds in it that we are very familiar with are produced in site-specific trichomes on the plant. You're going to be more efficient the more targeted you are in your approach to separation. Chromatography is a science, and it has diverse applications in making products as well as in analyzing products. Good extraction and analysis will help create accurate labels. Usually, there's some other issues with the supply chain, such as representative sampling and things like that. But typically, if you know how to apply your extraction methods and you know how to analyze the products appropriately, you should be able to generate accurate labeling. Pesticides are a concern for all workers in all parts of the supply chain, as well as the consumer. And so if you're a business and you're watching this, I'd think about those additional protections that you can do for your employees. Thank you so much for your attention. My name is Jahan Marcu, Chief Science Officer for Americans for Safe Access and Director of Patient-Focused Certification. Happy to take any and all questions related to cannabis.
Thank you, Dr. Marcu, for that informative presentation. We will now start the live Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just click on the Ask a Question drop-down box located on the far left of your presentation window. Type your question into the box that appears on your screen and click on the Send button. We'll answer as many questions as we have time for. So let's get started. Our first question is, what is the difference between sativa and indica?
That is a really great question. So sativa and indica is typically used by botanists to help distinguish what cannabis looks like. There actually isn't good evidence out there to say, oh, sativas have these compounds on them and indicas are this chemical variety. They just describe the fan leaves. Are they really narrow fan leaves like fingers, or are they more thick, fat fan leaves? So you have narrow leaf and broad leaf plants, and that's generally what sativa and indica describes. The first, most people don't realize this, but there's really only one indica specimen ever found, and in ethnobotany, if you find it, you get to name it. That's just how it works. And so Richard Schultes found Cannabis indica growing in the desert in Siberia, all alone by itself, and that was used to create the taxonomic identification. Today, everything has been so bred together that there is generally everything's a hybrid, and that taxonomic description, that nomenclature has been updated and is starting to be adopted. So sativa and indica is a great way to help track things, but it's not really the most scientific thing to use.
Well, thank you for that. Looks like we have time for one more question, and it is, are there approved pesticides to use on cannabis?
This is another great question. So because cannabis is Schedule 1, federal agencies can't offer typically guidance or approve things for it. Pesticides are typically approved for plants to use within certain windows. That being said, this public health issue and this responsibility has not been neglected by a lot of states. So they have felt the responsibility to put out an exempt list of pesticides to be used. You know, things like garlic oil or cinnamon oil, still stuff you don't want to inhale or get on your skin, but you know, things that are tolerance exempt. And I think this is important, and states are starting to come up to this. You know, for example, New Jersey doesn't allow anything to be considered a pesticide be used on the plant. For example, if you want to put water on the plant for purposes of killing insects, that's not allowed, but you can put water on the plant to water them. And so anything that's used as a pesticide is not allowed in some states because there is no federal guidance. Other states have adopted a tolerance exempt list if the pesticides are used within particular windows. And so I think when it comes to it, you want to use common sense, well, maybe uncommon sense, but typically, you know, you don't want to spray pesticides or stuff on fruiting bodies of the plant in late stage times of the plant, because then it will definitely be around in the final sample. And I think another consideration too about pesticides, if you do use cannabis on soil that has had heavy pesticide or heavy remediation, you should remember that cannabis is one of 200 species of angiosperms that is a bioaccumulator. It loves to suck things out of the soil like heavy metals. And hemp is still used to this day to help remediate soil in places like Chernobyl. But that's just a way of pulling it out of the soil, and then it has to be processed and disposed of later. So again, when we talk about standards for cultivating cannabis and things like pesticides, we want to be really careful and look to other crops that we know and love and are, you know, and there's integrative pest management approaches to make that safe for everyone involved.
Well, thank you for that. I would like to once again thank Dr. Marcu for his presentation. I'd also like to thank LabRoots for making today's educational webcast possible. Before we go, I want to let everyone know that today's webcast will be available for on-demand viewing through June 29th, 2018. You'll receive an email from LabRoots letting you know when this webcast will be available for replay. Please share that announcement with your colleagues who may have missed today's live event. That's all for now. Thank you for joining us. We hope to see you again soon. Goodbye.